Welcome to the most comprehensive series on limits. In the first two parts, we talked about the basic idea of limits and LHL, RHL and how to use it to solve complex JEE problems based on modulus and greatest interior function. In case you have missed that out, I will highly recommend you to go back and watch these two because that level of conceptual clarity and problem solving you won't be able to develop otherwise. But if you have watched that or you have got the basic idea regarding that, we'll move on to the next one, in which we are going to study the 7 techniques that we can use in order to solve limits. So we'll systematically start with factorization and move on to the next one. So without any further delay, let us start with it. So now we are going to start and discuss 7 important methods. 6 are written here. And then there is a 7th one, that is L'Hopital rule plus LH rule. And I usually teach LH rule or L'Hopital rule. So it is written L hospital but pronounced L'Hopital rule. Towards the end, because I first want you to develop these 6 techniques that would be very important in context and help you save at least 50% of time. So you might be able to apply this and solve few of these questions, but then you can't save this 50% time. Hence, it is not just important to know the LH rule, it is also important to know the 6 techniques. And as we move forward, we'll keep on taking the relevant JEE questions. We are also going to deep down and understand where to apply what. So if I talk about the first technique, that is factorization, this is the type 3. And in this, there are 2-3 important ideas that we need to know. So these are 2 very important factorizations that we have. We have x raised to the power n minus a raised to the power n. We can write it like this, x minus a. And then x raised to the power a minus 1, ax raised to the power n minus 2, we can go till a raised to the power n minus 1. Second is for x raised to the power n plus a raised to the power n. So we can write it in a similar manner. But here the important point is n needs to be an odd natural number. So most of the scenarios will apply the first one only, that is this one. Let me show you one application that will also give us this third standard formula. So let us say that if I want to get the value of limit x raised to the limit x tends to a, x raised to the power n minus a raised to the power n by x minus a, we can remove indeterminacy by factorizing the numerator. Let us see how. So I can write this as x minus a, x raised to the power n minus 1, a x raised to the power n minus 2, and we can go till a raised to the power n minus 1 divide by x minus a. We can remove this x minus a, substitute the limits. So this comes out to be a raised to the power n minus 1. This will also become a raised to the power n minus 2, and it will go till a raised to the power n minus 1. So you can see that all of these terms will become a raised to the power n minus 1. So we'll get this term n times. So we get a very standard and important formula for solving polynomial limits. Now few things to observe in this formula. So if I look into this formula, what are the important things? See, what is happening is, first thing that you should observe while applying this is, it should generate 0 by 0 form or in general indeterminacy. If it is not generating indeterminacy, then this formula is not required. Second thing is, when you are doing this, it could also be applied in general to cases where you have fx raised to the power n minus a raised to the power n. So this is generalization of the same formula. So what is happening is, in this scenario, when x tends to a, fx is also becoming a, and hence again we will be able to apply the formula in similar manner. So again we will get n into a raised to the power n minus 1. Once we know these 2-3 ideas, let us proceed to problems. Now into this question, you can see that before solving or directly applying the formula, what you should understand is this 0 by 0 form or not. So for that, we'll put the limits and see what happens. So this will become 1 cube minus 8 by 1 minus 2. So this becomes 1 minus 8 by minus 1 or 7. So you can see that this is not an indeterminate form. So we don't need to apply the formula and this will become my answer. Now if I change the question and here instead of limit x tends to 1, if I write x tends to 2. So what is written here is of quite importance. You can't randomly do it. Now we will express this in the form of standard limit and then do it. So we can write this as x cube minus 2 cube by x minus 2. So my answer becomes 3 into 2 n into a raised to the power n minus 1. The answer becomes 3 into 2 square. That would be equal to 2. Simple question. Moving forward, we have another question, x square minus root x. So now what you can do here is, we can again take a root x common. Before that, we have checked this is 0 by 0 form. So we can take root x common. What we have is x raised to the power 3 by 2 minus 1. And here we have x raised to the power 1 by 2 minus 1. Here we can multiply and divide by x minus 1. So here I am writing an x minus 1. Here I am writing 3 by 2, it won't matter. For the next part also, here I can write x raised to the power 1 by 2 minus 1 raised to the power 1. So I have multiplied and divided by x minus 1. What will happen if I distribute this limit? It will go to the first part. So I will write it systematically first time, then I will just do it next time. But you should understand, every time I am doing this, I am applying the same logic. 1 raised to the power 3 by 2 by x minus 1. And limit x tends to 1. 1 upon x raised to the power 1 by 2 minus 1 raised to the power 1 by 2. Now once we do it, what is going to happen? This limit is going to become 1. This is going to be 3 by 2, 1 raised to the power 3 by 2 minus 1. And this will become 1 upon 1 by 2 into 1 raised to the power 1 by 2 minus 1. Powers of 1 do not matter. So answer comes out to be 3. You can see that it is a simple idea of standard limits. Now here in this case, what is happening is, if I put the limits, this first term will become infinity, second will also become infinity. So this is infinity minus infinity. What happens is, when you will take LCM, in this case, this infinity minus infinity form will come either 0 by 0 form or infinity by infinity form, and then we can apply factorization and solve the question. This is the technique that we are going to use step by step. So first let us factorize this denominator. So what is written here is x cube minus 3x square plus 2x. So I can take x common. This will become x square minus 3x plus 2. And then I can write this as x into x minus 1 into x minus 2. Once you have written it like this becomes limit x tends to 2. 1 upon x minus 2. This becomes 4x minus 6 divided by x into x minus 1 into x minus 2. Then what we have is limit x tends to 2. We can take LCM. So x into x minus 1 into x minus 2. And if I multiply it, this will become x into x minus 1 here. And then we have 4x plus 6. And once I write it down, my first step would be done. So what I have done is I have taken LCM. If I simplify, this becomes x square minus 5x plus 6. And then x into x minus 1 into x minus 2. See, now here you can check. By putting the limits, it will become 0 by 0 form. So this was my step 1. I have taken LCM. As a result, in my step 2, it has converted into this form. Now I move towards my step 3. So I will refactorize it and solve the question. So limit x tends to 2. This can be written as x minus 2 into x minus 3. See, the 0 is getting generated because you have a term of x minus 2. Otherwise, it will not get generated. So other terms are not important. This x minus 2 is very important. Now this term will get cancelled out and indeterminacy will get removed. And if I substitute the limit through direct substitution, I will get my answer. So my answer becomes minus 1 by 2. So this is my step 3. So what I have done is I have used factorization to solve this question. This is my step 3. You can see that in all such infinity minus infinity form, we are going to use these kind of 3 steps to solve the question. Moving on, we have been given a question that looks like a question to the fx wala concept. If I remind you, I told you that here fx can also come if it follows the same rules of the game. So instead of x, I can also write fx. What was the condition? When x tends to a, fx should also tend to a. This should happen. Then we will also be able to write this as n into a raised to the power n minus 1. So in this case, what is happening is, this is x plus 2 raised to the power minus 5 by 2. A plus 2 raised to the power minus 5 by 2. You can see that this term is becoming equal to this term. So this part is fine. And in the denominator, if I just add 2 and subtract 2, I will get this similar kind of expression like this. And then we can apply my formula as n, that is minus 5 by 2. A plus 2 raised to the power minus 5 by 2 minus 1. So my answer becomes minus 5 by 2. A plus 2 raised to the power minus 7. So we can also, and this idea that I have told you here, this is a very interesting idea. This we will use quite often. So ऐसा नहीं कि यहाँ use होगा, it will be used quite often. Type 4 questions are based on substitution. Now we can further simplify certain questions like this question by doing some substitution. Let us see how. So in such kind of questions, what we are going to do is, it would make sense if I put 2 raised to the power x by 2 as t. So we can do this substitution because this looks kind of weird. This will become simplified. But when you do this, this will be my step 1. We'll have to change this limit also. So now in the second part, when x will tend towards 2, t will tend towards 2 raised to the power 2 by 2, that becomes nothing but 2. This is what is going to happen. Now once this happens, let us rewrite the question. So question becomes t tends to 2. This becomes t square. This becomes 2 raised to the power 3 by 2 raised to the power x. That again becomes t square. Then minus 6. And then this can be written as 1 by t minus 2 by t raised to the power 2 raised to the power x will become t square. Now let us simplify and see what happens. So this becomes limit t tends to 2, t raised to the power 4 plus 8 minus 6t square. On the other hand, in the denominator, what we have got is a t minus 2. Once you have taken this, now it becomes a question of factorization. Now this can be factorized into t square minus 4 into t square minus 2 divided by t minus 2. See, now understand that all the determinacy is getting generated because there is a t minus 2 term here. So frankly speaking, this term is not making any impact. So no need to factorize things that are not going to have an impact over answer. Now let us write it down. Only first term I am going to factorize. This becomes t minus 2, t plus 2, t square minus 2 by t minus 2. So you can see that t minus 2 gets cancelled out, and this is what was creating indeterminacy. So now I can directly substitute the limit and get the answer. So 2 plus 2, 2 square minus 2. This becomes 4 and this becomes 2. Answer comes up to 8. So this is the answer to this question. Going forward, another question is given to us. If I want to solve this question, again there is in limit x tends to pi by 2. Most of the times when we have solved the question, limit was tending towards 0. So again it will make sense to put x as nothing but pi by 2 plus t or h, whatever you want to put. So in the next step, what will happen? The limit will change. As x tends to pi by 2, t will tend towards 0. If I put x as pi by 2, you can see the value of t will become 0 corresponding to that. And if I do this, this will become sec of pi by 2 plus t. This will become tan of pi by 2 plus t. Once you have got this, it makes sense to simplify this to becomes limit t tends to 0. Sec of pi by 2 plus theta would be equal to nothing. It would be better if I write in terms of cos. So 1 by cos of pi by 2 plus t will become minus sin t. Cos t by sin t. Now it is correct. Now once you have this, I can take LCM. It becomes cos t minus 1 by sin t. If I write it like this, the answer comes out to be limit t tends to 0 minus 2 sin square t by 2. This can be written as 2 sin t by 2 by cos t by 2. This 2 will get cancelled out, sin will get cancelled out. Now if I put the limit, numerator becomes 0, denominator becomes 1, answer comes out. You can see that here when we have used factorization, we have used trigonometry to do it. We'll learn more about such questions in trigonometric limits. Now type 5 questions are based on limits of polynomial function. Let us understand. So now here you can see that if I generalize the older idea, I will be able to understand this faster. If the power of x minus 1 that is generating indeterminacy is smaller in the numerator, greater in the denominator, what will happen to this? Let us see. This will become limit x tends to 1, x minus 2 by x minus 1. Now you can see that it is no more an indeterminate form. In fact, if you check this out, this will come out to limit does not exist. If you check LHR RHR, you can see that this is what will happen if the power of numerator for that generates indeterminacy is lesser than denominator. Now in the next case, you can see that both the powers of x minus 1 become equal. What will happen in this case? So in this case, if I find the limit, this will cancel out. This will become x minus 2. If I put the limit, answer becomes 1 minus 2 minus 1. So in this case, you will get a finite non-zero answer. Okay. So what is happening is power of x minus 1 is equal. But there can be a third case where power of numerator is more than that of denominator for x minus 1 term. In this case, if you simplify it, this x minus 1 will get cancelled out. This is what is left. And if I put limit now, answer comes out. So in this case, you can see that the answer is always 0. So what we are doing is, if I generalize all of these ideas, it can be written simply as, if we have limit x tends to a, x minus a raised to the power n into x minus b into x minus c by x minus a raised to the power m, x minus d, x minus e. So what we are saying is there are three things that can happen. First thing is, if n is smaller than m. In this case, most of the times limit does not exist. Second is, if n becomes equal to m. In this case, you will get answer because of these four remaining terms. So it becomes a minus b into a minus c by a minus d into a minus c. And in the third part, the value of n would be greater than m. In this case, the answer will come out. Now let us move towards type 6 question that is based on rationalization. Let us understand this idea, what this idea says. Now, whenever you have a root in the question, obviously first thing that you should check is indeterminate form. Here you can see it is indeterminate form of 0 by 0 form. Now once you have checked that, the idea is basically whenever you say a root, the idea should be to remove the root. For removing the root sign, what we'll have to do is we'll have to rationalize it. And if I rationalize it, after that either factorization will happen or simplification will happen and we will get the answer. So let us understand in this case. So if I have limit x tends to 1, 4 minus root of 15x plus 1 by 1 minus x. So what we can do is we can multiply and divide by 4 root 15x plus 1 by 4 plus root 15x plus 1. If I simplify this, this becomes limit x tends to 1, 16 minus 15x minus 1 divided by 1 minus x. And this term, you can see that this term is generating no indeterminacy. So no need to touch those terms or play with those terms that do not add any value to the discussion. Once we have done this, now what we can see in the first part is, what we have is limit extends to 1. 15 we can take common. The first term will become 1 minus x by 1 minus x. This will get cancelled out. And we have 4 plus root of 15x plus 1 that is remaining. If I substitute my limit, this becomes 15 by 4 plus root of 15 plus 1. If I simplify, this comes up to be 50 by 8. You can see that by rationalizing this, we were able to get an answer. So when you have indeterminate form and a root sign, mostly you will have to rationalize. We can't generally say always, but mostly you will have to rationalize. But sometimes the question can be a little bit complex like this, and we'll have to go through the path of double rationalization. So what we will do is we will rationalize this in the numerator also. For that we are multiplying this part. And since we are multiplying, we'll also have to divide by it, and then whatever is in the denominator, we will write that part. So 2 minus root of 3x plus 1. So here we will put a plus sign, plus 3x plus 1. Now what will happen is, this will get multiplied to this part. This will get multiplied to this part and will rationalize. So as a result, let us write what do we get. So limit x tends to 1. This becomes 16 minus 15 minus 1. The denominator becomes 4 minus 3x minus 1. And what is remaining in the numerator is 2 plus root of 3x plus 1. Divide 4 plus root of 15x plus 1. Now once you have this in place, let us further simplify. Becomes limit x tends to 1. 15 times 1 minus x. 3 times 1 minus x. Multiplied by 2 plus a root of 3x plus 1. Divided by 4 plus root of 15x plus 1. This term that generates indeterminacy is gone. So we can put the limit. This becomes 5. This becomes 2. After substitution again becomes 2. 4 plus 4. The answer becomes nothing but 5 into 4 by 8 or nothing but 5 by 2. Again you can see that by doing double rationalization we were able to get an answer. Now always think before you act. That would mean if the question is given to you, you should always check what will happen if I put the limit. Like in this case, if I put 2, this is no more. In this case, if you put x equal to 2, you will see that this will not be indeterminate. In fact, we will check. If you put 2 becomes 4. This becomes 30 plus 1. This becomes 2 minus root 6 plus 1. This is not indeterminate. This is determinate. This will become the answer. What my point? So what you need to understand is always check the indeterminacy first and then solve the question. Now again one more question is given to us. Now in this case you can see that indeterminacy is getting generated because of this x minus 1. So 1 we can see here, there is a term. This we can again factorize in the denominator and see what happens. So if I do that, we know that one of the factors would be 1. So one of the roots would be 1. So alpha into beta is equal to minus 3 by 2. If we know that one root is 1, so beta will become 1 into beta. Another root will become minus 3 by 2. So this will help us factorize faster. So I can write it as limit x tends to 1. 2x minus 3 into root x minus 1. And enough denominator will become, now from here we know both the roots. So what we have done is we have used product of the roots to figure out the other root. So what we can do is we can write this as one root is x minus 1 and then there will be 2 and x plus 3 by 2. This 2 we can multiply to this term and can alternatively written as 2x plus 3 as well. So this term can be written as x minus 1 into 2x plus 3. And then, now in order to move the remove, if you want to, you can rationalize as well. So root x plus 1, we have written root x plus 1. If I simplify this in the next step, it will get solved. So we have 2x minus 3, that will have no impact, write it on one side. 2x plus 3 again, write it on one side. This becomes x minus 1. You have an x minus 1 waiting in the denominator, and then you have 1 by root x plus. These two terms will get cancelled out. If I put the limit, I get my answer. So 2 minus 3 by 2 plus 3 into 1 plus 1. My answer comes out to be minus 1 by 10. Now, I think you should pause the video and try solving this question. I have been solving on my own. But if you take an opportunity wherever you think that, okay, I will be able to handle this, take an opportunity, give it a try. Like in this case, if I put 1, you can see that numerator becomes 0. Denominator also becomes 0. So it is a 0 by 0. First thing to observe. Once you have this observed, the next part should be to rationalize it. And now it is based on double rationalization. So we'll have to multiply x square plus 8 plus root 10 minus x square for numerator. Since we are multiplying, we'll also have to divide. X square plus 8, root of 10 minus x square. And then root of x square plus 3 plus root of 5 minus x square. Root of x square plus 3 plus root of 5 minus x square. Now what will happen, as we did earlier? The numerator part will get multiplied to this part. The denominator part will get multiplied to this part. We can simplify and get the answer. So limit x tends to 1. This becomes x square plus 8 minus 10 plus x square. The denominator part becomes x square plus 3 minus 5 plus x square. And then you write the remaining part, root of x square plus 3 plus root of 5 minus x square divided by root of x square plus 8 plus root of 10 minus x square. Now once you have done this, what happens to the first part? The limit x tends to 1. This becomes 2x square minus 2. This also becomes 2x square minus 2. And these two part becomes cancels out. And what is left is nothing but the second part, x square plus 3 plus root of 5 minus x square divided by root of x square plus 8 plus root of 10 minus x square. Substitute the value, get the answer. So if I put 1, the first part will become 2. The second part will also become 2. The denominator becomes 3. The other part also becomes 3. So answer becomes 2 by 3. So like this, using double rationalization, we were able to solve the question. And what is the hint? The hint would be root given in the question. Now this question is given, it is slightly different. It is talking about finding the value of a and b. It is not asking you to directly solve the limit. So how do you tackle such kind of questions? Now for solving such kind of questions, we have slightly different method. So what we do is, first we check the indeterminate form. So I will put x equal to 0. So my numerator becomes root b minus 1. Denominator becomes 0. Now what they are saying is this limit is finite. What I am getting is root b minus 1, the denominator, numerator, denominator is fine. So for this to become finite, see if root b minus, so there could be two scenarios now. Either root b minus 1 can be equal to 0 or root b minus 1 cannot be equal to 0. See, in this case, the answer will be infinite, positive or negative, but infinite. But since it is finite, so this can't happen. This needs to happen. So what we are saying is root b minus 1 will be equal to 0 or b would be equal to. See, understand the logic one more time. What I am telling is, this is what we are getting after directly substituting this x equal to 0 in this question. So what can happen is this numerator part, either this could be equal to 0 or not equal to 0. Now if it is not equal to 0, in this scenario, the answer will become infinite. Since they have given that the answer is finite. So this needs to be 0. There is no way around it. If I solve, I get the value of bs1. Now once you have done that, in the second part, what should happen? Let us substitute the value. I get limit x tends to 0. This becomes ax b is 1 minus 1 by x. We have been given the value of this limit. So what we can do is we can rationalize it. So now limit x tends to 0. If I rationalize, I should get my answer. So I can rationalize this by multiplying and dividing by ax plus b plus 1. So root of ax plus b plus 1 by root of ax plus b plus 1. Now this is equal to 1. Let us see what happens if I rationalize. So once I do that, my answer comes out to be, numerator will become ax plus b. Now here b we already know is 1. So instead of b, now I am writing 1 minus 1. And what is left is a, and then root ax plus b plus 1. So this will get cancelled out. X will also get cancelled out. It becomes a determinate limit. If I put x as 1, sorry, x is 0. If I put x is 0, what I am getting is the denominator also, this will b is 1, so will become 1 plus 1. So answer of a comes out of it. So you can see that there are two parts of the question. In the first part, we have checked indeterminate form, and from there we were able to get value of one of the unknowns. And in the second part, what we did was we did rationalization, and solving that we got another condition and another value. So this is very important thing, and we will do this question using multiple methods. This is one of the ways of solving it. Now moving forward, there is a 2024 JEE question that came on JEE 27th morning shift, and it talks about two limits in one question. So you can see that this is what has been recently happening, that they ask in one question multiple questions. So let us take this limit one at a time. So if I want to find the value of a, this will become limit x tends to 0. If I rationalize this, and I am doing it faster now. So if I rationalize this, this will become 1 plus root of 1 plus x raised to the power 4 minus 2. You can see that I have orally rationalized it. And since I have rationalized it, the same term I will write in the denominator also. So 1 plus root of 1 plus x raised to the power 4 plus root 2. So this I have multiplied and divided. Now you can see that one more part I have got as a result. So limit x tends to 0. This will become root of 1 plus x raised to the power 4 minus 1 by x raised to the power 4. And root of 1 plus x raised to the power 4 plus root 2. And now again we can rationalize using root of 1 plus x raised to the power 4 plus 1. Root of 1 plus x raised to the power 4 plus 1. Once we simplify, this becomes limit x tends to 0. 1 plus x raised to the power 4 minus 1. Given x raised to the power 4 waiting for this, it will get cancelled out. And what is remaining in the denominator is 1 plus root of 1 plus x raised to the power 4 plus root 2. And then also one more term, 1 by root of 1 plus x raised to the power 4. I can substitute the limits and get my answer. So it becomes 1 by 2 root 2. And this will become 1, 2. So answer becomes 1 by 4 root 2. So like this you have got the value of a. A is nothing but 1 by 4 root. First part of the question this time. In the second part, now they have given us another limit that we need to solve. Let us figure out that. So let us call that as b. So for solving the b part, we'll again have to rationalize. Again I will directly rationalize without writing things, because we are doing a JEE Mains question. Lot of things we need to do orally. So if I rationalize, I will get root 2 plus root of 1 plus cos x here. If I rationalize it, what is happening? This will become 2 minus 1 minus cos. So if I simplify this, my answer becomes limit x tends to 0. This can be written as 2 sine square. That will become 4 sine square x by 2 cos square x by 2. Next term is root 2 plus root of 1 plus cos x. And the denominator is simplified, will become 1 minus cos x. That can be written as 2 sine square x by 2. So now you can see that very clearly. This part and this part is getting cancelled out. This will also cancel out, will become 2. As a result, I will be able to get the value of p. So now if I write and put the limits, this becomes 2. Putting x equal to 0, cos term becomes 1. The next term will become 2 times root 2. And denominator is already 1. So answer becomes 4 root. Now let us look into the question. What they are asking is what is the value of a times b cube. So what will happen is if you multiply a times b cube, it will become 1 by 4 root 2 and 4 root 2 whole cube. So what we will get is 4 root 2 whole square. That would be 16 into 2 or 32. Let us check the option C matches. Now this question came in 2019. Again, you can see that we can rationalize and directly get the answer. So in the first step, we are going to rationalize it. Since there is a root sign, if I rationalize, this becomes 2 minus 1 minus cos x and into root 2 plus root of 1 plus cos x. So this comes out to be limit x tends to 0. And this is sine square x. This is 1 minus cos x. And this is root 2 plus root of 1 plus cos x. Now once we have this, we can simplify it further and get the final answer. So limit x tends to 0. Sine square x, this becomes 2 sine square x by 2. This is root 2 into root of 1 plus cos x. If I simplify this, this becomes limit x tends to 0. 4 sine square x by 2 cos x square by 2 by 2 sine square x by 2. This becomes root 2 plus 1 plus cos x. This terms gets cancelled out. And then if I put the limit, this becomes 2, this becomes 1 and this becomes 2 root. So my answer comes out to be 4 root. Let us check the option. A option matches. Let us move towards another question that came in 2019. Again, we can rationalize and get this right. So if I, and now you can pause the video and try solving this question. So now if I rationalize it, it will become 1. We have done rationalization one time. 1 plus y raised to the power 4. This becomes minus 2. Divide by y raised to the power 4. And since we have multiplied by root of 1 plus root of 1 plus y raised to the power 4 plus root 2 in the numerator, we will also multiply it in the denominator. So once you have got this, answer becomes limit y tends to 0. Root of 1 plus y raised to the power 4 minus 1 by y raised to the power 4 into 1 by root of 1 plus root of 1 plus y raised to the power 4 plus root 2. And then you can again multiply and divide by 1 root of 1 plus y raised to the power 4 plus 1 by root of 1 plus y raised to the power 4 plus 1. And again it will become rationalized. So we can write the answer as limit y tends to 0. 1 plus y raised to the power 4 minus 1 by root of 1 plus root of 1 plus y raised to the power 4 plus root 2. And then we have one more term, that is a root of 1 plus y raised to the power 4 plus 1. Now we can see that this will cancel out, this will also cancel out. We will put y as 0. So my answer becomes 2 root 2 here. And this part will also become 2. So it becomes 1 by 4 root. So you can see that option A matches. Again, we move to this 2019 question. I think now you will be able to do this. If I rationalize it, I should be able to get my answer. So it is x plus 2 sin x. If I rationalize it, the denominator becomes x square plus 2 sin x plus 1 minus sin square x minus x plus 1. And then you can multiply in the numerator also. Root of x square plus 2 sin x plus 1 plus root of sin square x minus x plus 1. Now, if you simplify this, you can see that we are getting the same term that we are getting in the numerator, x plus 2 sin x. This will also simplify as nothing but x plus 2 sin x. And then you have root of x square plus 2 sin x plus 1 plus root of sin square x minus x plus 1. This gets cancelled out. And if you put 0, the first part becomes 1. The second part also becomes 1. Answer comes out to be 2. You can see that B option is correct. So in this video, we talked about two very important techniques. One is factorization, another one is rationalization. I hope you enjoyed it. We covered all the important problem types and problems that were asked in JEE. Now in the next one, we are going to jump into two more important techniques, that is infinite limits, how to handle them. And second would be series expansion and how to use it effectively to solve questions. And lots of JEE questions are asked on these two ideas. So if you have been following this series till now, I will highly recommend you to stretch it and watch the videos that are going to come next. If you keep doing this with a lot of sincerity and keep solving the homework that is given with this lecture notes, you will develop a lot of confidence on this topic and definitely you are going to get the question right in the exam. See you until next one.